We've mentioned reference angles before, but today we're going to look at them a little bit differently. Instead of just saying our reference angle's position, we're actually going to find the value of that reference angle and kind of why we need them, okay? So on our coordinate plane here, when we rotate 210 degrees, we're going to start at our initial side, and if we remember, this is 90, 180, and then this is 270 and back to 360. When we rotate 210 degrees, we're going to rotate past 180, and we're going to be somewhere here. And if we remember, our reference angle is between the terminal side and our x-axis. So when I'm asking for the reference angle, I'm looking for this. I want to know what this angle equals. This angle is the difference between our 210 degree rotation and 180. So this angle is going to be 30 degrees. And the reason why we need that is so we can find the trig values of that angle. For example, if I were to ask you to find the sine of 210 degrees, so far the only way we know how to do that is with our right triangles. So we got a right triangle, my angle is 210 degrees. We can build our opposite and adjacent to find our sine, right? Wrong. What do we know about triangles? Triangles have an interior angle sum of 180 degrees. So there's no way to build a right triangle with an angle of 210 degrees, right? So how do I find the sine of 210? That's where our reference angle is going to come in. So we have the angle that's 210, but we can build this right triangle with a reference angle of 30. So now I could actually ask myself, what's the sine of 30? So I'm going to get rid of that 210. Just based on scale, my 30 is going to go up here. And now I can build that triangle. We know with our 30, 60, 90, this is 1, 2, and root 3. So my sine of 30 is 1 over 2. But based on where 210 is, we went left, and then we went down. So this is a negative 1 over 2. So the sine of 30 is 1/2. But because we're in that third quadrant, we are going to get negative 1/2. That's extending the idea of why we use reference angles. Those reference angles are going to help us find those ratios with our bigger angles of rotation. So right now we're just focusing on finding our reference angle. So here I've got the angle 318. 318 degrees is between 270 and 360. So it's somewhere here, and we're going to go ahead and refer back to the x-axis to find that reference angle. Our x-axis here is 360 degrees, so I'm going to take 360 and find the difference between the 360 and our angle. So that is going to give me 42 degrees. The reference angle is 42 degrees. 112, that's between 90 and 180, so it's going to be in here, and we're going to refer down to the x-axis. So what's the difference between 180 and my angle? So 180 minus 112, that's a 68 degree angle. Our reference angle is 68. And 87, that's in the first quadrant, somewhere around here. We refer back to the x-axis, and our reference angle is going to go down to the 0. 87 is our reference angle. Because we're in that first quadrant, our angle will be our reference angle. Yeah? Okay, it gets a little bit trickier, but not too terrible when we deal with our radians. So what I'm going to do is I'm going to change my coordinate plane here. I'll go ahead and just sketch a new one right here for us. we go to 0, pi over 2, pi, 3 pi over 2, back to 2 pi. And now we're going to look at our reference angles in radians. 5 pi over 4, if we think about that as a mixed number, this is 1 pi and pi over 4, right? So it's going to be somewhere around here. We're still referring back to the x-axis to find that reference angle. Well, we have that 1 pi, and we've gone pi over 4 past pi radians. That reference angle's right there. I gotta sneeze, I'm sorry. Sorry. So 5 pi over 4, my reference angle is pi over 4. 2 pi over 3, it's not quite a full pi. A full pi would be 3 pi over 3 to get 1 pi, right? It's somewhere around here. We refer back to our x-axis. We're going to get our reference angle. We're missing a third of our pi. So pi over 3 is our reference angle. It's right there, right? Then we got pi over 6. Pi over 6 is in the first quadrant, so our reference angle is pi over 6. You have a sixth of pi. Let's just do one more just real quick. Let's say we had 11 pi over 6. So this is a full pi plus 5 pi over 6. So it's going to rotate to pi, and now we have 5/6 of a second pi. So that's going to take me here. And we're going to refer to 2 pi. So how do I get to 2 pi? Well, I'm missing the last pi over 6. So that reference angle is pi over 6. That's one of the cool things about radians is a lot of times the reference angle, it's all given to you. It's a lot easier to find than in degrees. A lot quicker, it's giving you more information. Okay, we're going to use these reference angles moving forward. If you got questions, let me know. Like and subscribe, hit the notification button, do whatever you got to do. Watch my videos.